Hello friends, welcome to this tutorial. Here we will discuss on LeetCode problem number 1935, which is maximum number of words you can type. So here we have given a string text which contains a word separated by a single space, and then we have given another string which is broken letters, and this string contains all distinct letters that are broken, and we need to return a number of words in text that we can fully type. So what does it mean here? Let's understand with example. So here we have this string text. It contains two words, right? Separated by a single space. And then we have this another string which contains broken letters characters. So A and D, right? Which means that we cannot type A and D character, right? So we need to return that how many number of words in the text we can fully type. So if the character that we want to type, right, in this word, if it exists in broken letter, then of course we will not be able to type that character, and hence we will not be able to fully type that word itself, right? So the simple goal is this word, right, should not contain any character which exists in broken letter. Simple. So if you see here, hello, right? Does H exist in broken letter? No. E, no. L, no. O, no. So we can simply type this word, right? Now let's go to the second word. So does W exist in broken letters? No. O, no. R, no. L, no. But D, yes. So if any of the character of this entire word exists in the broken letter, that means we cannot fully type this word, and hence we will just return one here. Similarly here as well, we will check the characters from this particular word. Does L exist in broken letters? Yes, so we cannot type this. Then again we go to the next word. Does C exist in the broken letters? No. O, no. D, no. E, no. So we can type this word, hence we return one here. Let's consider the third example as well. Here, if we see E of this particular, the character E from this particular word exists in the broken letter, so we cannot type this. Similarly, we cannot type this as well, hence we return 0. Let's understand the constraint as well. So here the text length is in between 1 and 10 raised to power 4. The broken letter length is in between 0 to 26 because it contains only distinct lowercase English letters only. The text consists of words separated by a single space, yeah, and it doesn't have any leading space or trailing spaces. That's good. And then each word only consists of lowercase English letters. Okay, fine. Now let's try to understand how we will solve this problem. So first we will have declare a variable, let's suppose result, which will store the count of the words that we can fully type, and this is what we need to return as well, right? We will start looping the string text here, right? We will also maintain one flag which will say that can I type this word or not, right? So I will just simply initialize it with true. I am assuming that I can type this word, the word that I am iterating. Okay. Now we will start from 0th index. So I will check H. Can I type this? Yes. Then I will check E. Does E exist in broken letters? No, so I can also type this. Then I will check L. I can also type this. Again L. I can type this. Then O. I can type this as well. Now I get the space, right? So as soon as I get a new space, that means the previous word is completed and the new word is starting, and the new word will get a start, right? So I will check this flag, right? If this can type is true for previous word, that means I can type this word, right? So if can type is true, sorry, so I can type this word and increase result count by 1. Simple, right? And also I will set can type to true again for next word iteration, right? Again I will go to next word now. So I will go come at W. W, can I type this? Yes. Can I type O? Yes. Can I type R? Yes. Can I type L? Yes. Can I type D? No. So as soon as we found any character in the word which we cannot type, we will assign can type to false. Right? Now my can type is false. And I am done with the string, right, after D. So I will again check the scan type field. Now since scan type is false, will not do, will not increment result, right? Hence I will just simply return 1 here. Easy. Now let's go how to code this. So similarly, how I explain here, we just need to type have the same logic in the code as well. So first we will have this result integer variable which will store the count, and then we will have one boolean flag which is can type, which we will set to true initially. Now what we can do here is how to check whether this particular character exists or not in broken letters. It will be very difficult for us to again loop this string again and again, right, for each iteration. So what we can do is we can have one hash map, maybe empty, which will store the broken letters, right. So we will first iterate through each character of broken letters, and then we simply assign the value in the hash map as true, or maybe we can just rename it as broken, right? So it will be, so these characters are set to true. Now we just simply need to check this value, and we don't need to iterate this string again and again, right? So now what we will start looping this text string. First thing is, if ch is equals to space. If there is a space, right, then what we will do, we will see whether can type is true, right? If can type, that means if it is true, then we will increment the result by 1, and we will again store the can type as true for the next iteration. Simple. If it is not, right, if there is some value, that means we are still looping that particular word, right? So we will see that else if this particular character that we are looping here, right, if it contains in is broken wala is broken map, right, that means this is a broken letter, right, or a broken character, right? So if this is true, if this particular character is broken, then what we need to do, We need to simply update the can type as false. If any of the character is broken, that means we cannot type, and hence I am updating the can type as false, right? So that we will not increment the result count here. This is what we need to do, right? Now I will just simply return result. Have we completed the code here? No. There is one more check we need to do for the last word, right? So for the last word, we will not get this if condition here, right? So again, we need to apply this if condition here, that if can type is true. This is basically for the last word, because once we iterate through this, we will not have any further space, right? So whether to decide should we increment the count for this word or not, we need to leverage this particular flag again here, right? So if can type, then we will just simply return the result count for the last word, right? Now our code is completed. Let's try to run this. Okay, our test cases are passed. Now let's submit this. Okay, this is accepted. Now let's try to understand the time and space complexity here. So first we will go through the time complexity. Here we will go through each and every character of broken letters. But then broken letter itself can be of maximum 26 character only. So we just don't need to bother about the time complexity of this, as it can be maximum of 26 character only, right? Then we will go to the each character of this text. So if text is of uh, text contains n character, that means we will loop this for n times. Hence, our time complexity will be O of n. Now, what about the space complexity? So we have declared this unordered map, right? But it can contain maximum 26 character only. So the space complexity will be O of 26, which is constant only, right? Which is constant only. I hope you understand this code and the way we are calculating this time and space complexity. If you do like my video, then please, if you understand this video, if you understand how I am explaining the problem and the way we are solving this problem, then please do like and subscribe and share this video to your friends. Uh, yeah, thank you.